We said before that the CPU is responsible for executing some kinds of instructions. So each CPU has its own defined set of instructions that it's able to execute. So as you might guess, this is called the instruction set. So for example, one type of CPU that you might have in your Apple computer is an Intel CPU. And here I'm on Wikipedia here, and what this is a list of all of the different instructions that this CPU can understand. So I can scroll through here, I can see these are some more, and then we can add in some new instructions that are kind of developed as processors went on. So different processors have these different types of instructions or things that they can do. So let's actually scroll back up to the top here and just look at a few. So for example, this instruction here, this says add. The instruction add is not an acronym, it just means add. That means this instruction can be used to add two numbers together. So scrolling through, it seems like a lot of these are kind of at that same level, right? We can add numbers, we can compare numbers, we can decrement a number by 1. Nowhere in this big page is it going to be something like open a web page, right? These are all extremely, extremely low, simple, super simple instructions that are kind of as simple as it gets. And that's the level of instruction that your CPU is dealing with. We can't just tell your CPU, OK, save this Word document. That process of saving a Word document is broken down into a really, really small number of subprocesses, for example. So let's take a task like opening an email. So let's say that we're going to open our email, and there's no open this email instruction that we can send to a CPU. So what are some steps that are kind of required that your computer might have to perform to open an email? Anyone have any ideas? So not CPU instructions, for example, but like, let's say, for example, I have to download the email. That's kind of a step in the process of opening an email. So what could another step be, for example? Yeah, exactly. So how about we display it? So once we've downloaded the contents, we're going to display this email. So let's take this task. I want to display this email and break it down even farther. So how can we break this down of displaying an email? What's something your computer has to do? Yeah, exactly. So we need to know where to display it. So we can even break that down even farther. We have to say, OK, here in the projector screen is a really small pixel. What color should that pixel be? It could be a result of the email text, or it could be what the kind of the chrome around your window. Maybe the X button is in that pixel. So suddenly we can see that this large task of opening an email, we can really, really break down into really small levels. And that's the level of instruction that your CPU is actually dealing with. So we have a few different types of instructions that we can give to your CPU. So the first of these types in your instruction set is called a data instruction. So what that could mean is I want to read or write some value from memory. So maybe I'm on a web page, and as we said, we want to remember what page we're browsing. To do that, I would need some kind of data instruction. So if we flip back to my list, or Wikipedia's list, and we look at this thing here. So this is the MOV instruction for move. And it says that this is going to copy data from one location to another. So this means that there's some data that I need to store. And I want to take that data, and I want to move it to RAM. And so we'll see exactly what that means in just a little while. So that's nice. But one of the more important ones is things like arithmetic. So we saw before that this could be adding two numbers, incrementing a number, dividing. Basically your very simple mathematical operations. Something like solve this equation is not going to be an instruction that your CPU can actually execute, because that's too high level. We're really dealing with only simple things. So finally, we might have an instruction called a control flow instruction. So we said that programs like Google Chrome are these big sets of instructions, kind of like a shopping list. And so it could be the case that sometimes while executing this long list of instructions, we want to skip a few or kind of jump back a page. So kind of like reading one of those choose-your-own-adventure novels. So I used to read the Indiana Jones choose-your-own-adventure novels, and those were super awesome. So sometimes you'd hit a page, and that page would tell you, don't go to the next page. I want you to jump to page 53. So that's kind of what these types of instructions will say. They'll say, I don't care what you're doing right now. I want you to jump over here and start executing this instruction. And the CPU doesn't really know why. The CPU isn't going to ask Google Chrome, hey, why are you making me jump back there? That's kind of weird. It's just going to do it, because that's the CPU's job, is to just execute the instructions that it's given. So let's now take a look at the process of actually executing one of these instructions. So to execute an instruction, we're going to put it through something called a pipeline. And the pipeline is the CPU's way of breaking down one of these simple instructions, like add two numbers together. We're going to break it down even further. So you can consider the pipeline to be just like an assembly line. So when we're building a car, there's probably multiple steps to building the car. So we could do things like assemble the frame, put the tires on, and all these other car things. But there's multiple steps to accomplish this one instruction that we can give that says build a car. So similarly, our CPU is going to have these multiple steps or phases inside of our pipeline that once an instruction is put all the way through the pipeline, will have the result of that instruction. So the first step in our pipeline is going to be the fetch step. And this says that I need to figure out what instruction I need to execute. So somehow these instructions are being fed to the CPU. The first thing we need to ask is, well, what do I need to do? So remember that these instructions are going to be stored in binary, because that's what our computer is capable of representing data in. It's all zeros and ones. So now the next step is now I have this binary thing, this just sequence of bits that somehow represent an instruction. So the next thing the CPU needs to do is figure out what instruction that is. So it needs to go from the sequence of bits to something like add these two numbers together or copy this data into RAM. So that's called the decoding step. We're kind of decoding this cryptic series of bits into something the CPU can actually understand. So next up, we have the most important step, the execute step. So this is what's actually going to run the instruction. So we're going to get the result of adding two numbers together or actually move this data from RAM. And finally, we have this write back step. So this says if, as a result of executing something, I got some result. Right? When I added two numbers together, I get some new number. I probably don't just want to throw that number away, right? Or else why did I calculate it in the first place? So in this step, we're going to say, OK, with that result, I'm going to put it somewhere. And we're going to see the various places the CPU can put it in just a bit. But now this is simply so we don't do all of these mathematical operations in vain. And so this is just kind of one example of a pipeline. And so as we'll soon see, different CPUs have different pipelines that might have different steps or many more or even fewer steps than this. So this is just kind of a simplified version of the pipeline that hits all of the major concepts that the CPU is going to need to execute. So this is by no means the authoritative all CPUs will use this pipeline. This is just kind of an example, high-level example. OK, so let's take a look at an example. So let's say that we're putting this thing through our pipeline. So we execute our fetch phase, and that fetch phase returns us a series of digits like this. And I have no idea what this means, and neither does the CPU. So we need to run it through this decode step. So as we saw in that big instruction set, a CPU has this big list, kind of like a dictionary, of all the things that it can do. So when we get this instruction like this, the CPU can decode it, and it first needs to figure out what it needs to do. So in this example, I've randomly said that in this instruction, these first 8 bits are going to tell me what I need to do. So this is called the opcode, or the operation code. And that's going to tell me what operation do I need to perform. And so this is just kind of a made-up thing. And I've randomly said that the instruction, the number, what number is this in binary? 2. Exactly. So we said that the number 2, well, I'm going to say that that corresponds to the add instruction. So in my big dictionary of instructions, if I look up the number 2, that tells me that that corresponds to the add instruction. So now I'm just going to say that the second half of this instruction, these other 8 bits, this is going to tell me what numbers I need to add together. So these are called operands. They're kind of extra information that we can add to our opcode to tell it more information about what to do. So the instruction add doesn't really mean anything, right? We need 2 things to actually add together. So here I'm just saying that in this instruction, the second half here represents 2 numbers. Each of those numbers is 4 bits. So this first 4 bits is one number. The second 4 bits is some other number. So this could be what, for example, the instruction for adding 2 numbers could look like. And so now decode says, I'm a CPU. I know exactly what all of these instructions are going to look like as they're coming in. And I know to look at the first 8 bits for the opcode and the second 8 bits for the operands. And I can figure out that this series of bits just means add 5 plus 3. So you don't need to worry about the specifics of how we decoded this series of bits, because it's just kind of one example way of the CPU representing it. It could represent this instructions. What's important is just that the decode step just goes from some series of bits to something the CPU can actually understand, like 5 plus 3. So the specifics are not important. So finally, the execute phase, we're going to say, OK, I have this instruction. I know what to do. I have a 5 and a 3, and I'm supposed to add them. So let's actually do that. We'll execute and get 5 plus 3 equals 8, and that's our new result. So finally, we need to do something with that result. And we can do something inside of this write-back phase. And this says, with that 8 that I just got, I can now put it somewhere before I move on to the next instruction. So any questions on this process? Yeah?
The slide that you had on there before, in terms of the binary, you had add, you got that one, add 5 and 3. So the add, basically, that particular number of binary goes into 5 and 3 in terms of telling it what to do.
Yeah, so this for example, yeah, no, exactly, that's exactly right. So this is, for example, just a single instruction we might get. And somewhere inside of this instruction is something to do, like add, and then something to add, actually add, like these two numbers. So this isn't how every CPU might represent add two numbers. This is just an example of going from how we could go from a series of bits to an actual instruction that we can understand.